IRIS initially got started as a challenge from our leadership to put forth a project for Spark Tank in 2018. We had built a fuels trainer for hands-on training and communication to better help our airmen learn their job in a safe environment. And the next step was having that communication in the tank.
The fuel cell guys are working on a 65-year-old aircraft, and the technology they're using for communication is no different to when they started. They yell at each other, they yank on the air hose, they knock on the side of the aircraft, but that is the limit of their communication.
The lack of communication when you're in a metal box is astounding. It's really hard to explain to people how difficult it is. You're supposed to maintain constant contact with the entrant in the tank. They are in an area that's barely big enough for them to move around in. They could be 20 to 30 feet from where they entered the tank at. And they will have a respirator on. They'll hear their piped air over everything else.
Walking into the Spark Tank is the IRIS team, an idea for safely enhancing communications while working in confined spaces.
In February 2019, we took this to Orlando to the World Warfare Symposium and presented to Secretary Wilson and Chief Wright and a few other people on the board. And we were very lucky to receive funding to go ahead and make IRIS. Our group commander at the time was watching football one weekend and saw that the footballers had cameras on their helmets. And he did a quick Google search and found that Action Streamer were the company providing those.
So Action Streamer, we're a technology company. We're based here in Cincinnati, Ohio. And we're a platform for streaming wearable devices. So our technology is used to integrate streaming cameras into things like sporting equipment. For Project IRIS, we've taken our core platform approach and applied it to this respirator use case.
Our main focus for the project was just a good solid video feed so we can see what the entrant is seeing, then the communication part, so if they needed something or they had a question, they didn't have to exit the tank.
We have tried to focus very much on keeping this simple. We want a plug-and-play wearable that the guys can just pick up, put on, and go to work. It's not about being cool and fancy. It's really just about the core issue of solving the communication gap that we have working in aircraft.
So our IRIS solution consists of a set of enclosures with our electronics that mount onto the respirator. And then there's also a laptop computer that allows a technician to interface with the maintainers that are wearing the technology. So this is both video and very robust, clear two-way audio, along with letting third-party folks actually look at and see what the maintainer sees. And we can route that video content not only to a screen, on a laptop, but also via commercial video conferencing to really folks all across the planet.
So we've come out to Cincinnati to do some testing. We went up to AFRL and we used their C-130 wing, and we were predominantly focusing on the lighting. Was it bright enough? Was it too bright? Was it at the right angle? Was it the right flood? And that went really well.
Normally in the tank you're either carrying a handheld flashlight, you might have a headlamp that sometimes it's not always at the best angle. With IRIS's built-in lights, they're pointed in the right direction, they're where you're looking. It was light, and that's what you want your technology to do. You want it to be usable and help you, but you want to forget that it's there.
We also wanted to test the angle of the camera because it's a fixed angle, so we wanted to make sure that in all the different positions someone might work, that it would all be at the correct angle with the camera and that the attendant would be able to see enough of what the person was doing. And it worked extremely well.
So then we did some audio. They got to get in and actually see what it was like for someone to be talking to them.
The throat mics were so incredibly clear. It was very easy to hear the person wearing it. So we hope going forward from here that we will be able to get a fully intrinsically safe prototype. We hope to get this on the guys in the fuel cells to really get some use out of it and get some strong feedback. And I'd like to see that happen at RAF Mildenhall, but also potentially at Sergeant French's unit in Kadena, to see how it works in different environments. Beyond that, we'd really like to see this produced commercially. We want to see this taking over the world for all confined space entrants. There's something like 20 million confined space entries every year, and this is something that could be really useful for all of them. We'd also like to see it in use for emergency services. We were out with the fire department yesterday and they were really enthusiastic that this could be very useful in hazardous environments.
IRIS isn't just about the communication when maintenance is going on. IRIS is going to be there to help protect the entrant.
This is going to allow us to improve their safety vastly, because we will know the instant anything is wrong. The other thing is just the time. It's the time it takes to transfer in and out when something's not quite right, or you've forgotten something, you need another opinion on something. We'll be able to do that instantly. You'll be able to have their point of view from the camera, and you'll be able to talk to them in real time, back and forth. You could talk to a group of 6, 7, 20 people. This could be scaled up and down. So you could have a whole team of experts helping a single person out in a space that you couldn't physically fit 2 people into. So it's going to make a huge difference on the time spent. And that, for the Air Force, certainly means our aircraft availability rates will increase drastically.